Yep, you guys are seeing that right. 1.0 degrees outside at 4 o'clock in the afternoon. We're on our way down to a low of somewhere between -12 and -17 tonight. And the big snowstorm last night was a complete flop. We got about an hour's worth of snow yesterday morning. And then the snow turned over to rain, which we ended up accumulating about a ½ inch of rain. And then last night, around 9-10 o'clock in the evening, it turned back to snow. And after that, it quit snowing. It might have snowed for maybe an hour or so. It quit snowing. The winds picked up to about 20-25 miles an hour. And the temperatures dropped off, and it was hovering just about 8 below this morning. And the sun's out now, so it's up to just about 1 degree above. And I'll tell you what, it is chilly out there, folks. I was going to take some video outside and some pictures and stuff, but I'll tell you what, just a few seconds out there and you'll want to get back inside and bury yourself deep, because it's cold out there. For those of you that were paying attention last evening, I posted a part 5 to the Stewart Warner radio restoration, and I didn't really care for the way that video went. I'm trying to give you guys a good product here, and there's a lot of stammering and stuttering, and just I wasn't happy with the way the video turned out. And I got a few comments, you know, most were positive, and I got some good information. So I gathered that information, and I figured, you know, I'll make a better video out of what I gathered information-wise from the comments, and what I learned poking around with this transformer since I seen you last. Now, I've been able to correctly identify all the wires on this transformer, and then figure out what I'm going to do with the color scheme. I'm not going to change it much, just a little bit. But first, let's get in here and test this thing. And this time it's all AC voltages, whereas last time on my multimeter I was dancing back and forth between AC and DC. This transformer is AC input, AC output. It does not convert over to pulsing DC until it goes through our number 80 rectifier tube. So I'll pause the camera and get the multimeter hooked up, and we'll test our voltages and see what we have. And here we are, all connected up. And you remember last time I couldn't get no voltages off of these 3 wires right here in particular. But then I realized I had my multimeter set in the wrong scale. This has a 600 volt AC/DC selection, and it has a 200 volt AC/DC selection, and then a couple smaller voltages below that which we can't use. I had it set to too high of a range. So let's try this again. I'll increase the variac up to 115 volts input, and this will show us what we have for an output. And those 2 wires, these 2 big guys right here, are 2.8 volts, and they go to our number 5135 suppressor, noise suppressor tube. So that voltage is acceptable, because that tube wants to see 2.5 volts, and this thing's outputting 2.8 volts no load. So that's okay. That's what we want to see there. So I'll turn the variac back down, and what I'll do now is take one lead off of those wires, and I'll hook over here to this center tap. Now, we couldn't figure out, or at least I couldn't figure out, what this wire did. This wire puts out exactly half the amount of voltage of what the 2 black wires do. And there you have 1.4 volts. That's our center tap. That's what that should be. That wire is used for biasing on the noise suppressor tube. So that wire's good. In addition to supplying 2.5 volts to our suppressor tube, this is also what powers the filament strings and the rest of the tubes on the chassis. These two black wires here and here. So, let's go over here to the other side, and we'll hook in right there and right here. And once again, we'll turn it up to 115 volts. And we'll increase our range. And we'll increase the variac just a little bit. And we have 5 volts. These two wires are the filaments for the 80 rectifier. Now, I want to show you part of what these two dark brown wires do right here with this meter. This meter can give me the voltage on the center tap, which is this guy right here. These two brown wires go to the plate of our 80 rectifier, and they are super high voltage. They should be, in excess of 700-800 volts. I can't test that with this meter. I can only test up to 600 volts. So what we'll do here is we'll pick one of the sides, doesn't matter which one. We know that they're both good. We'll hook one side of our tester to one side of our plate wires that go out to the 80 rectifier, and we'll hook the other side to our center tap. And let the meter reset, and then we'll increase the voltage to 115 volts output. And there we go. Our center tap voltage is 432 volts. And I verified that by also connecting to this other brown wire right here, and then the center tap. Now I've got a special treat for you. We're going to have to use a different old school gauge for testing the two center tap lead, or the two plate leads for the 80 rectifier. Now this old meter is a Dynascan Precision 120M, and I bought this a long time ago. I think I bought this meter probably in my late teens. I'd say somewhere between 16 and 18 years old at an antique mall for 15 bucks. And this is a very unique meter. For continuity, it uses 2D batteries, and it has an output feature right here you can connect into that uses a 15 volt internal battery through the output connection in your common ground to test things up to 15 volts. And this is a super heavy duty laboratory volt ohm meter, and it'll test all kinds of milliamps, 120 milliamp, 600 milliamp, up to 12 amps, low voltages of 1.2, 12, 3, 60, 300. You get over to the AC side, you have 60, 300, 600, 1200, and up to 6,000 volts. And then over here you have 1.2 milliamps. I'm not sure, these are like, I'm not sure if that's microamps, milliamps. Looks like a backwards U and a capital A. And then you have your resistance from R times 110 to R times 10,000, and you have an ohms adjust and a transit setting which disconnects the leads. And you can set this thing polarity on the DC. You can reverse it or make it normal, or you can set it in the AC function. And you can also test up to 6,000 volts DC with this thing. Now, being this is capable of testing 1200 volts AC, it's perfect for testing these two plate leads on this transformer for voltage. Now how this thing is read, our scale we're looking at, and you probably can't see it because it's kind of faded, is right above this silver band right here. And each big mark is 100. And by the time I get this uploaded to YouTube, I'm sure that'll be very grainy. Let's go ahead and flip the meter on, or the variac on. Make sure we're setting our correct positions on the meter, which we are. And this thing has always had a problem of resetting to 0 when it's in the stand-up position. If you lay it down flat, it's right back to 0. Let's go ahead and give her some juice. That's about 20 volts, not even that, 10 volts AC. 20 volts, 30. Alright, sorry about that. My memory card was full on my camera. Had to run up and put it back on the computer and bring it back down. So anyway, we're sitting at 40 volts AC input, and we have just a little over 300, about 350 volts output on these two brown plate leads to our 80 rectifier. It's 50 volts, 60, 70, 80, 90, 100, 110. Here we are, just about. About 115 volts right there. And we're reading 2, 3, 4, 5, 6, 7, 8, 880 volts to our plate. That's these two brown wires here and here. And don't dare touch them or anything around me. 880 volts AC to the plates of our number 80 rectifier tube. So I consider this a complete success. Everything works good. My old meter didn't let me down. So we can go ahead and start changing the leads on this transformer. Now I wanted to show you this diagram here, the schematic. This is the power supply of the Stewart Warner 110 chassis. Our two white wires, which are these guys right here and here where the power cord's connected in, are these two right here. That's where 115 volts come in on the primary side of our transformer. On our secondary side, these two big guys right here, which are 2.8 volts output, are right here on the schematic, here and here. And they supply filament voltage to the number 35 or 51 noise suppressor tube, and from there it feeds voltage to the rest of the filaments in the radio. Now, our center tap, which is this guy, his voltage is read by connecting one of our test leads between here and one of these two black leads, which we know we have 1.4 volts. On the diagram, our center tap, this guy right here, 1.4 volts, 2.8 volts. Okay, let's look at the other side of this transformer, where I still have the test leads connected. Those are our plate connections to the number 80 rectifier tube. That's these guys right here and right here. And we have roughly between 860 and 880 volts on those two. Now our center tap, which is this, I'm going to call it yellow wire, that's what it's going to be replaced as, is a yellow. Again, we connect our one lead between one of the brown wires, our plate connectors, our plate wires to the 80 rectifier, and the center tap. And when doing so in that combination, we get exactly half of the voltage. And here's that guy on the schematic. That's the other half of our center tap. Now, back here, these two black wires here and here are the filament wires for the 80 rectifier. And again, they're displayed on this diagram right here and right here. And the symbol for the filaments right there. And from there they go off and feed power to the electrolytic capacitors in the power supply before going through a choke system, the voice coil of the speaker, out to a audio output transformer, and all that compromises our power supply. Pretty cool, huh? You know, it took me a while to figure that kind of stuff out, but once you sit down and you study this stuff and enough people talk to you, It's pretty easily understood after that. Just stick with it. Don't get frustrated. I know a lot of these guys, they'll whiz right through this stuff, but they've been doing it for some time. Me, I'm still in the learning stages. So, you know, this Stewart Warner over here, this guy, he's teaching me some valuable information about a transformer radio. So, you know, I didn't know how to read what this was when I first took this apart, a transformer. I didn't know what the center taps were, and the plate leads, and the filament leads, and primary and secondary, and you know, I didn't know what all that stuff was, but it took some time. So, we can go ahead and change the wires on that. It's a little too cold to do any kind of painting right now, so the clamshells are going to have to wait. I'll go ahead and change the wires on this guy, and we'll take a look back in that, either the next part or the part after that. And I haven't really given you guys a real good look at this chassis since I brushed the dirt off. Very little, if any, rust on this thing. It's pretty clean. But I do have some questions for you. Down here in front, try to get some good light on this thing. Down here in front, behind the tuner, turn it a little bit more. Right here there's a rubber bushing, and that's used for the tuner to tune, and it should drive this gear right here. Where do I find something like that at? And I also need the grommets for the tuner that go through the chassis. See how loose he is? And I know I'm putting the cart way in front of the horse, but we're going to need a dial scale for this thing, and this is not a very big dial scale. Let me see if I can find the other piece of it. It's pretty tiny. There's the low end of the broadcast band. And I don't think it says Stewart Warner on it or anything like that, but it does have a little number down here in the corner. It says 83107, and I looked that up on our parts diagram, and that's its part number. No luck for me searching one of them out, but I thought I'd reach out to you guys and see what you all think about that one. Okay. Other than that, you guys have seen the underside of this thing many a times. We got a box capacitor to change. A lot of dog bone resistors, which we're going to try to make our own. This thing is pretty much all in all original, except for a couple of Utah capacitors paralleled right there in series to make a voltage that obviously wasn't available. And I wanted to show you all too, since the last time I seen you, I don't think I've brought this up. And I know I told you I was going to restuff these capacitors, which I've got to order some. I still haven't done that. But we're going to slip these yellow capacitors inside the old tubes. And then we're going to wrap that capacitor with like some cardboard or something, make it a little bit bigger so it fits in that tube good. And then we'll fill it up with clear glue, and then I'll cap the ends off with some dark brown hot glue. And here's our dark brown hot glue. Bought these off of Amazon. I think they were kind of expensive. I think they're around $5 for, I think there's 10 sticks in here, 10 or 12 sticks, doesn't matter. But that's what we're going to cap those tubes off with that the capacitor set in. So guys, that's about it for now. Like I said, I wanted to do you all a better job on this part 5. You know, kind of a little gun shy about stuff sometimes I'm not quite sure of, so I get to yammering and, you know, stuttering around and stuff. And it'll all be learned with time. So thanks for watching, guys. And there will be more to come later. And stay warm. I just looked over there, and the time it took me to make this video was just about 45 minutes. It's already minus 1.3. See you guys later.